Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about photochemistry. So, question is, what is photochemistry? You can see in this picture, it's reaction of matter with light. Now, characteristic of light. Light is equal to band of waves of different wavelength. You can see the lambda, you can see the time and origin. So increase in the frequency, that is the energy, increase in wavelength in nanometer. So 400 to 700, this scale is increasing in wavelength in nanometer, and 700 to 400 increasing in frequency, that is the energy. Now, electromagnetic spectrum important for photochemistry. You can see here the electromagnetic spectrum: gamma ray, X-ray, ultraviolet, visible, infrared, microwave and radio wave. So gamma rays to radio wave, wavelength is going to increase. Now, what is wavelength? Distance between successive crest or troughs. What is frequency? Number of crests or troughs that pass a point per second. Speed of light, c is equal to nu lambda. What is the solar energy? Solar energy is equal to h nu. It's the energy come from the sun or other radiant source. The dual nature of light, it means that in some experiments light behaves as a wave. In other experiments light behaves as a particle. Now, particle characteristic of light. Light means flux of discrete unit, means quantum, called photons. You can see here fireworks. So we have to define the absorbance, color and transparency of materials. Transparent materials absorb no light in the visible wavelength range and hence have no energy states separated by between 1.65 and 3.10 electron volt. You can see here SiO2, glass, quartz, diamond and water-soluble polymer like polyacrylic acid, PPA. So absorbance, color and transparency of materials. Continuing of this point, opaque materials. What is opaque materials? Opaque materials are absorb light in all the visible length range and hence have many energy states separated by between 1.65 and 3.10 electron volt. For example, graphite also absorbs light at all wavelength but is back and not reflective like emitter. Some metal, copper and iron are colored as well as reflective. You can see in this picture. Now dyes. Dyes and many other materials may be colored because they absorb some of the wavelengths in the visible region. You can see in this picture. UV absorbance sunscreens. Absorbance in the ultraviolet range is important for transparent materials. UV is higher energy light, and UV absorbance can lead to photochemical reactions and the formation of highly reactive free radicals. As with the ionizing radiation, these can lead to cell damage and skin cancer. You can see UVA 320 400, UVB 280 to 320, and UVC greater than 280 nanometers. So this is the longest wavelength range. This is the sunscreen seeks to block these regions of the spectrum. And most energetic photons, little solar UVC, reach the surface of the earth. Now, ordinary radiations, thermal or dark radiation. It occurs by absorption of heat energy from outside in the absence of light. You can see in picture number 1, the reacting molecules are energized. Then you can see the molecular collision is occurred. So steps of ordinary reactions. Energy surplus, water molecules, and product is formed. Now photochemical reactions. It's a reaction which takes place by absorption of the visible and ultraviolet radiations, 200 to 800 nanometer. Photochemical reaction leads to the heating of atmosphere during the daytime by absorption of ultraviolet radiations. You can see in this picture how it is working. Now photochemical reaction include the absorption of visible radiations during photosynthesis. Without photochemical process, the earth would be simply a warm, sterile rock. You can see in this picture of sunlight and plants. So schematic of photosynthesis in plants, the carbohydrates produced are stored in or used by the plants. Look at the reactions. Carbon dioxide, 6 molecules water, in presence of light, it is giving sugar and oxygen. Overall equation for the type of photosynthesis that occurs in plants. Now, my friend, photochemistry. It's the branch of chemistry which deals with the study of photochemical reactions. The demonstrations of a photochemical reactions. You can see H2 plus Cl2 in dark, no reactions. H2 plus Cl2 in light, formation of HCl. So you can see the demonstrations. Now difference between photochemical and thermochemical reactions. Photochemical reactions, these involve absorptions of light radiations. The presence of light is the primary requirement for reactions to take place. Temperature has a very little effect on the rate of photochemical reactions. Del G for photochemical spontaneous reactions may be positive or negative. Photochemical activation is highly selective. The absorbed photon excites a particular atom or group of atoms which become site for the reactions. On the other hand, thermochemical reactions involve absorptions or evolution of heat. These reactions can take place in dark as well as in light. You know, my friend, temperature has a significant effect on the rate of thermochemical reactions. Del G for a thermochemical reaction is always negative. So thermochemical activation is not selective in nature. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching. Wait for second video.